Alright, ladies and gentlemen, in this video we are going to continue our discussion on circumference, but specifically focus on arc length. So today in this video we're going to look at arc length, its formula, and use it to find length of an arc and the radius, or possibly even the circumference as well too. So let's think about this just for a quick second. When I say arc length, we all know what an arc is by now, but the circumference is the entire distance around this circle. So when I'm talking about arc length, I'm talking about maybe a specific portion of that particular circle, right? I'm talking about specific portions of the circle. So we have a formula that goes along with it, and really it's just a ratio. What we're saying is that the arc length, we'll talk about AB right now, this portion of the whole circumference is to the circumference, 2 pi r, remember 2 pi r, c equals 2 pi r, just as the measure of its arc, the measure, not the length, the measure of its arc is 360. Remember, an arc has two things. It has measure and it has length. So let's take a look at a couple examples of a couple different scenarios. In our first one, we want to find out what the measure of the arc actually is, the measure of the arc length. I want to know what the length is. And so we're going to go ahead, and let me change color just to make sure it's a little bit more clear. So for part A, remember, arc length over circumference, which is 2 pi r, equals the measure of the arc over 360 degrees. All right, well, remember, this is a central angle. This central angle will equal its corresponding measure of its arc. So the arc will also be 60 degrees, not 360, 60 degrees. And so the arc length, I'm going to call it x for now. I'm going to call the arc length x. So x over 2 pi, and our radius is 8, so I'm going to substitute 8 in there, is equal to 60 over 360. Now, just to kind of make life a little bit easier, I'm going to go ahead and just simplify our right side a little bit more. And 60 over 360, well, 360 divided by 60 is 6. So 60 goes into 60 once, and 360 6 times. So it just makes our cross multiplication a little bit easier. So I get 6 times x equals 1 times 16 pi. And then I can divide and get 16 pi over 6. 2 goes into 6 3 times and into 16 8 times. So my final answer will be 8 pi over 3. And I'm going to keep it like that unless it says to round, because that's an exact answer for our arc length. What about if we want to go ahead and find the circumference using one of the lengths? It's the same formula, folks. Arc length, which in this case is 4.19, over the circumference. Remember, the circumference is 2 pi r. If I want the whole circumference, I'm just going to call it c, because I could care less of what the radius is at this moment in time, is equal to its arc measure, which is 40 degrees, over 360. I can cross multiply. I get 40c equals 360 times 4.19, which is 1508.4. And if I divide that by 40, I get that the circumference is approximately 37.1 inches around. So that would be our entire circumference there. What about one final one, where I go ahead and I want to use the arc length formula to find a specific measure of it. Now, how do I know to outline that one? Well, 2 letters, that's a minor arc. 2 letters, that's a minor arc. So for part C, I know that once again our arc length, which in this case is 44, over the entire circumference, which is 2 pi times the radius of 15.28, and that is going to equal the measure of RS. And I'm just going to go ahead and call the measure of RS theta for right now. So theta over 360. We'll cross multiply. And just to kind of make our life a little bit easier here, I'm actually going to go ahead and multiply this out. 15.28 times 2 is 30.56, and then times 3.14 for pi is going to be 95.96 roughly. So 95.96 times theta will equal 360 multiplied by 44, which is 15,840. And then divide that by our 95.96 to find out what the measure of the arc is, which is going to be about 165.1 degrees. And again, that is going to equal the measure of the minor arc, RS.